the some
త్రీకి కంప్లెక్స్ మీటింగ్ అట వాళ్ళు మళ్ళీ ఏదో స్టూడెంట్స్ లిస్ట్ సరిగ్గా లేదు అని అంటున్నారు.
So I request the participants to keep mute yourself. So because this session was recording currently. So at the same thing, I want to keep it in YouTube channel for the benefit of the participants. So if you have any doubts while doing the assignments, they can refer this video, online video. So if you keep it in your mic in mute position, that will be more better. So coming to the, I'm trying to compare the artificial intelligence AI with natural intelligence. The natural intelligence or human intelligence, what we have. So let's assume, simply I am to tell one thing. Let's assume I have a 5 years child. So for that 5 years child, so I want to make him keep it in a school. I want to join him for a nursery or LKG, UKG, whatever it may be. I send him to a school. For the purpose is, so that kid, my child will learn something. What is required for his better future. So now, so I want to compare that child, the brain that child have, that is called as a model. Okay, I hope you understand. I have a son. I want to join him in a school. For the purpose of to make him to join in the school, because he will learn something which is required for him for his better life. So I joined my child in a school to learn something. Now coming to natural intelligence, so we can see that child as a model. So which can be compared with the artificial intelligence, that is called as a model, like maybe call it as a machine learning model, or it may be called as a deep learning model, whatever it may be. The child in the natural intelligence or human intelligence can be represented as a machine learning model or deep learning model, because in the artificial intelligence, we will build the machine learning model or deep learning model to learn something based on the historical data, based on the problem on which the model have to work. That means, suppose if I want to build one application to forecast the electric power load on a substation, now what I will do, I will take one machine learning model or deep learning model and I will feed the historical load data. Then that model will learn how the patterns are going on, and that model will learn how loads are varying with respect to some features. From once it was trained, once it was learned, then if you give some input feature to your machine learning model or deep learning model, then your machine learning model or deep learning model able to predict the load. The same way in our natural intelligence, what we are following human intelligence, I have a child, I keep him in a school to learn something. Maybe we can call it to learn ABCD. So once he learned ABCD, for the next class he is able to identify the words, and the next class he is able to identify the sentences. So like that he will be learn. So when I was joined in my school, I don't know what is A, what is B, what is C. Now I learn, whenever I saw A letter, then I can easily recognize this is A. Coming to my son, he don't know anything when he about to join for the school. Once he joined in the school, so when he starts learning the alphabets, later if he see any alphabets on the car number plate or on the bike number plate, he tell that, Dad, this is the T, this is the S, this is the A, and this is the P. So he is able to recognize, he is able to identify. So same fashion we are developing the machine learning model also. So you can build an analogy between your human child brain and with the machine learning model or deep learning model that is used in the artificial intelligence, right? So but fine, okay, so that is called so the child's human brain so can be correlate with the machine learning model or deep learning model. Now what next? Fine. So if the child want to learn something, so what we are going to give? So we have to give the information, we have to give the some data, right? So that means, suppose if my son joined in a English medium school, so at starting they may give some books which consists of some letters like words like some characters like A, B, C, D, alphabets like that. So that all the information that consists in the form of the books that will be given to my child, that is the information, that is the data on which the school want to make my child to learn. Hope you understand. So when I join my child to a particular school, then the school will give some books. So if he is in the nursery, they may give some books containing of words, characters like A, B, C, D, or numbers like 1, 2, 3. That means that is the information. Based on that information, based on that data, the school wants to make my child to learn alphabets and the numbers. That means if our child want to learn something, we have to provide some information like A, B, C, D, 1, 2, 3, 1, 2, 3, or Telugu letters, or whatever it may be. So that information is required to make our child to learn something. So what is the analogy for that? So even though only machine learning model is available, that is not sufficient, because so you are developing a machine learning model for a particular purpose. That may be a to predict the electric power load, or that may be a requirement to predict the electric price, or that may be predict the diagnose the some diseases like a COVID, or that may be able to diagnose the disease plants, or that may be able to identify the type of disease. So there is, for every model there is a specific requirement. So on that requirement I am trying to train the model. So now similarly, if my child want to learn something, so the school will give the information or some books that containing the ABCD 1, 2, 3 like that, because they want to learn my child in that area. Similarly, suppose if I want to build some machine learning model or deep learning model to make my model to learn something and able to predict some load, then what I have to do? I have to feed some data to my machine learning model based on the required problem. On which problem I want to use that machine learning model for prediction. So that data you have to feed to your machine learning model. So the analogy is the ABCD 1, 2, 3 books, whatever it may be, the schools are providing in the human learning process. So that can be correlated or can be taken as the analogy for the data in the artificial intelligence or in the machine learning. Hope you understand. So that human child brain can be analogy for the machine learning model or deep learning model in the artificial intelligence. And so once my child is joined in a school, the school will give some information in the form of the books like A, B, C, D, 1, 2, 3. So based on that data, that information, my child will start learning. Similarly, if you want to build some machine learning model, some deep learning model for a particular application, then you have to provide the data based on the requirement. Hope you understand. So based on which problem you want to work on the machine learning model, on which problem that machine learning model need to work. So based on that you have to feed the data. So for example, suppose if I want to build some machine learning model or deep learning model to predict the COVID, whether the patient have a COVID or not, then what you have to do, maybe label is one label. So you can give some features. This is like a case that I'm giving some features like maybe based on fever, based on cough, based on cold, and based on oxygen level. So based on these features, you are going to diagnose whether the patient has a COVID or not. Like assume the fever is around 98.6 and the COVID no cough and no cold, oxygen levels are oxygen O2 is 100%, definitely he is good, so he will be labeled as a 0, that means no COVID. Suppose like a fever is 1 or 2 and cough is S and cold also S and oxygen levels are very less 86, then he may be diagnosed as a COVID patient. So like that you have to prepare some data based on your problem requirement. So based on the problem or based on the application you want to build the machine learning model, accordingly you have to prepare the data and feed the data to your machine learning model, and based on that data your machine learning model will learn something. Once the machine learning model or deep learning model learn perfectly, trained perfectly, then if you give some unseen data, then your model able to diagnose whether the whether the person has a COVID or not. So this is how generally they happen. So in our schools also, initially the school teacher will provide the information like A, B, C, D like that. So my child starts learning A, B, C, D. So from after some time, when he saw some A, P, R, T, S, then he identified that this is the word, this is the character T, this is the S, he is able to identify because he already learned, his brain already trained. So that's the analogy for the human learning process and machine learning process or deep learning process. That's fine. In these two areas, till now we didn't see the optimization, then you may raise a question, why we are discussing about the optimization? So it is a model, human child is a model, machine learning is a model. Here AI side we are using the data, in the human learning we are using the information. Then where we use the optimization? Then I will come to the one more example. See, when a child join in the any nursery or whatever it may be, see, for all the students, almost the information is same. Generally, they will learn A, B, C, D, or 1, 2, 3, or whatever it may be. Then why we will choose a particular school rather than some other X school? What the why? Why we choose some X school apart from the Y school, even though the Y school is nearby us? Because so we got some information that that school is better for our child. They will give the good education for our school, for our child, right? So that is the, so what it may be the school give the good education means, that is what strategy that schools are following to make our child to learn based on this available data. Okay, so different schools follow the different strategy, right? So maybe some schools will ask the child, our child to write a multiple times. That what we follow when I was a first year class student, first class student. So till now maybe instead of slates they may use some other books, whatever it may be. So there is a different strategy. Some schools may ask the child to write multiple times, and some schools train our child based on some activities, and some schools may train our child by showing some videos. So different strategies they are following. So different schools are following the different strategy, right? So that means the schools are following different strategy. That strategy is useful to our child to learn the words, to learn the alphabets A, B, C, D or numbers 1, 2, 3. So different schools follow the different strategy. The school which follows the good strategy, the school which follows the strategy but that makes our child to learn easily, so we will prefer that school to join our child. So that strategy will be the analogous in the machine learning to the a topic called optimization. Okay. So strategy means the schools are following some strategy. So as I said earlier, once again I want to repeat. So when we join our child in a particular school, so the schools are following some strategy. Some schools are following to write our child the alphabets multiple times. Some schools will follow the strategy, activity-based strategy. Some schools may follow the strategy by showing some videos, or some schools may strategy to that means one person will tell A, and remaining all students will shout like A, like the different strategy will follow. So different schools follow the different strategy to make our child to learn based on the available data to survive in his life. In the same way, in the AI side also, artificial intelligence or machine learning or deep learning also, we have a data. That means maybe the data related to the COVID patients, we have a data, and I want to develop the machine learning model. So this data will be useful to my machine learning model to learn something. Then who will tell how the machine learning model will learn? Data is available, machine learning model is available. Then what is the algorithm? What is the procedure to learn? That is given by the optimization methods or optimization techniques in the machine learning. So optimization is a very play a crucial role in the machine learning. The optimization techniques will help the machine learning model to update its model parameters. Optimization method will help the machine learning model to learn based on the available data. So the optimization technique will help the machine learning model to learn based on the available data. So optimization technique will help the machine learning model to update its model parameter based on the available data. Hope you understand. So that's why at the basic of if anyone want to, if anyone is a very basic level of the machine learning is very first time want to know about the machine learning, that's better to go with the optimization. Optimization plays a crucial role. That optimization method will help the machine learning model to update its model parameters to, and optimization method will help the machine learning model to learn something based on the available data. So if you provide the good optimization technique to your machine learning model, then the machine learning model parameters will be updated based on the available data. Once the updation was successfully updated, then when you give some new data, your machine learning model is able to predict very well. So hope you understand where we require the optimization in the machine learning. So, and one more thing I want to tell. So Sir told that multiple times, so that the machine learning model, machine learning model, machine learning model. What is the machine learning model? It is very simple. So machine learning model is nothing but some mathematical operation in the backend. So that's why generally, I think maybe 5-6 months back, I saw one article in someone's WhatsApp status. That is, one instructor asked the students who want to learn AI, machine learning, or deep learning. Then most of all the participants in the hall raised their hand. Then he asked one more question, that is, who want to learn mathematics? So then no one raised the hand. But reality is, if you are good in mathematics and if you are good in programming, then you can rule AI. So mathematics and programming both are the very, very important things if someone want to learn machine learning, deep learning, or artificial intelligence. So nothing but, so machine learning model or deep learning model is nothing but some mathematical operations behind the model that was generally encapsulated. We don't know. But if we want to learn something, you have to know beyond that one. Don't see it as a black box. Don't see ANN as a black box. Don't see distance tree or whatever it may be as a black box. So you have to know how it will work. So then you, if you are a research scholar, then it is very helpful to you to come with some good models or good machine learning models. Instead of using all the existing model, you can come up with a new machine learning models. You can build new machine learning models. That will be happened only if you are able to understand the mathematics that will be happened back end of your machine learning model. Hope you understand what I am to tell. So machine learning model is nothing but some mathematical operation, MO, mathematical operations behind. That mathematical operation will give the relation between some input and output. The mathematical, the back end of every machine learning model will have some mathematical relation, which will develop some mathematical relation between your input and between your output. So machine learning model, deep learning model is nothing but something else. It is simply a mathematics. Some mathematical relation will be established behind the machine learning model. That mathematical relation will give the relation between your input features and your output feature. That means, so these are called as the input features and this is called as the output feature. Your machine learning model try to build some mathematical relation between your input features and your output feature. Hope you understand that the machine learning model. Okay, so in the machine learning model backend, you have some mathematical expressions, mathematical relations in the form of some model parameters. So the mathematical relation between the x and y in the form of some model parameters. Those model parameters will be updated during the training process. We are going to identify the best model parameters based on your application, based on your problem. Hope you understand. So don't worry. So coming next classes, you are able to understand. So simply, I want to tell one thing. So machine learning model is nothing but a simple mathematical model. Not simple. It's a mathematical model that provides some relation, mathematical relation between your input features and output features based on some model parameters. So during the training process, what happened is, during the learning process, what happened is, so your model parameters will be updated to get a best correlation between best relation between your input feature X and the output feature Y. So your training of a machine learning model is nothing but simply updating your model parameters so that you will get the good output based on your input features. You can get the accurate output based on your input features. That all happened during the training process. During the training process, your optimization technique will play a vital role. The optimization techniques, optimization algorithm will help the machine learning model to update the model parameters so that there will be a good correlation happening between your input features and your output feature. So that when we give some inputs, that model is able to predict accurately your requirement. Whether your model is for the COVID diagnosis, it is able to diagnose the COVID very perfectly. If your if your machine learning model is developed for the some cancer prediction, your model is able to diagnose the cancer very well. If your model is developed to predict the electric power load on substation, then your machine learning model is able to predict the electric power load on substation perfectly. That will happen only if your model parameters are updated properly. So how the machine learning model parameters will be updated? That is based on the optimization technique. Okay, so hope you understand what is the role, what is the need of optimization. So optimization technique or optimization method or optimization will help in the machine learning to update the model parameters of a machine learning model based on your data that you feed it. So the data which you are feeding to your machine learning model, based on that, your model parameters will be updated using the optimization technique or optimization algorithm. Hope you understand. Simply, I want to tell one thing. What is the role of optimization in the machine learning model? Machine learning. If someone asks you, what is the role of optimization in the machine learning? So optimization is used to update the model parameters of a machine learning model or deep learning model, which was developed as per our problem specific. Based on the problem specific. That means, so if you have a linear regression model that can be used for the load prediction, that can be used for the temperature prediction, that can be used for the price prediction, whatever it may be. So based on your problem requirement, based on your data, your model parameters will be updated based on the optimization technique. The optimization technique is used in the training process. The optimization method is used to update the model parameters of the machine learning model during the training process based on the available data. That's it. Hope you understand what is the role of optimization. Next task is we are going to discuss about the optimization. What mean by the optimization now? So slowly we will move. So optimization means, so what mean by the optimization? So optimization can be simply defined as, so optimization is a process of maximizing or minimizing a particular objective function. Okay, so optimization is nothing but the trying to maximize or trying to minimize a particular objective based on some constraint, based on some decision variables, then it is called as the optimization. Everywhere we are using the optimization, right? Suppose if we went to DMart, as a customer, what we feel, so we want to purchase all the required goods, groceries, which were sufficient for 1 month at lowest cost. So that means we are trying to minimize our expenses, and the constraint is what the groceries we are purchasing that will be sufficient for the 1 month. So that is also optimization. So here in this case, in this optimization, I am trying to minimize the expenses. I am trying to minimize my expenses, monthly expenses. Hope you understand. So my strategy will be like that. So my strategy will be, so when I am going to the DMart, so I have to purchase the groceries, all the required groceries which are required for 1 month at the lowest cost, at a minimum cost. So I'm trying to minimize the cost of expenses. Minimize cost of expenses. So that is my objective. So that is also an optimization problem. And what is the other side? What DMart people will do? They are trying to maximize their profit. Okay, so how they can maximize their profit? They are thinking in that direction. So that is also an optimization problem. So everywhere we are using the optimization. So either we are maximizing the objective or minimizing the objective. Okay, so some objective, whatever it may be. So that's called optimization. So how this optimization problem looks like? So that optimization problem will be looks like. So we are trying to maximize or minimize a particular objective function x1 and x2. Let us assume. So then it is called as the optimization problem. So optimization is nothing but the maximizing or minimizing a particular objective function, particular objective. So that is called as your optimization. So see one thing, whatever the client requirements are there, whatever the requirements of your supervisors, whatever it may be. So the clients will give the requirement as a text data. They will give the requirement as a text data. So now, if you are engineer, so if you are the programmer, then what you have to do? You have to convert the text data as a numerical format. You have to convert that into the number format or numerical format. Later, try to solve the optimization problem, because no client will give the problem in the mathematical format. So they will give the problem as a text format. Suppose, let's assume I will show some case studies in the next coming minutes. So the clients will give the problem statement like a text data. Sometimes they will not give the text data also. If you are working for a company, your company has some client and you are going for the client meeting, they will give his requirement orally. You have to prepare the data. You have to prepare the document. And you give the document to our engineers, and the engineers will build some mathematical models based on the data, text data that you are providing. So later we have to write the programming. Everything will be done. So why I am telling all the things means your optimization problem, don't see that what the numbers, why you use all these numbers. So actually you are probably not in the numbers. Like suppose, for example, I am telling, let's assume I am working as an engineer for a company X. I am working as an engineer for a company X. Okay, in my company, I have my manager M, and my company has a client C. Then my manager will go to the client and speak with the client. Your client may give his requirement as a text format, or he may give he may give his requirement as a instructions. Then what your manager will do? He will take a up of all the requirements as a text data. Yes, these are the customers want to minimize his monthly expenses, and he want to the customer want to purchase all the groceries what are required for the complete month. Like that, all the instructions he will note it down and give that instructions to your engineer, to me. Then what I will do as an engineer, as a program, what I have to do? Now I have to prepare some mathematical modeling. I have to prepare some mathematical modeling based on the instructions submitted by my manager. Once the mathematical modeling is ready, then I go for the programming, and later I will come with a solution. Okay, so that's why I am telling all the things means this mathematical, this objective function looks like a mathematics, but in the real time it's not a mathematics. It is in the some instructions, some text. We have to convert into mathematics. Okay, fine. So finally coming to the optimization means trying to maximize or minimize a particular objective. Trying to maximize or minimize a particular objective function is called as optimization. And in every optimization problem, there are some crucial parameters or main parameters are there. They are called as, one is called as objective function, another is called as constraints, another is called as constraints. Okay, so the function which we are trying to minimize or maximize, the function which you are going to minimize or maximize is called as the objective function. The variables which decide the value of the optimization objective function, the variables which decides the value of the objective function are called as the decision variables, are called as the decision variables. The function which are going to minimize is called as the function which we are going to minimize is called as objective function. The variables which decide the value of the objective function are called as the decision variables. So in addition to these two, there are a few terms are called as constraints. Constraints means, so there are some constraints will be exist while solving the problem. So in our DMART case study, what is the constraint? Constraint is whatever the groceries I am going to purchase, that will be sufficient for a whole month. What are the groceries I am going to purchase in the DMART, that will be sufficient for the whole month. That is my constraint. So I have to fulfill that constraint, at the same time trying to minimize the cost. Right? So minimization of the cost is the objective function, and the sum of the total groceries which are sufficient for the total month is called as our constraint. So that is called as a constraint. So like for example, I am trying to minimize some objective function 3x plus 5y subject to some constraint like x plus y less than or equal to 1 and 2x plus 3y that's equal to 10. So these are called as the constraint, and this is called as the objective function. So see, this is some mathematical modeling of an optimization problem. This is the mathematical modeling of an objective optimization problem. Based on the instructions given by my manager, I developed the mathematical modeling, and this mathematical modeling is formed like this. So this is the example for the optimization problem. Why it is called an optimization problem? Because we are trying to minimize a particular objective function. So this is called as the objective function, which we are trying to minimize. That is called as the objective function. And this objective function value is depending upon the two variables called x and y, and these variables are called as the decision variables. Okay, so we have to calculate the x and y decision variables at which your objective function 3x plus 5y will be minimum, subjected to the constraints are the value of x and y, summation of values of x and y should be less than or equal to 1, and 2x plus 3y must be equal to 10. Just example I am telling. So 2x plus 3y must be equal to 10. So these two are called as the constraints, and this is called as the objective function, and x and y called as the decision variables. These are the crucial parts in every optimization problem. Okay, so every optimization problem has an objective function, every optimization problem has the decision variables, every optimization problem has the constraints. Okay, just a minute. Some people are outside the lobby, in the lobby. I am trying to allow them. Yeah, sorry. Fine. Please, please. Yeah, fine. So hope you understand the how optimization problem will be appear. Are you able to see this screen? Yeah, I think so.
Yes, sir.
Yeah, thank you. So this is the format of the optimization problem that contains. So your objective function which you are going to perform, and whether you are going to minimize or maximize your objective function. I request the participants keep mute yourselves. Some vada pollution. If you keep it in mute, that will be more helpful for me. So the session was recording actually.
Of my spelling of my all recently.
Right. I request all keep it mute. Yeah, fine. So hope you are able to understand how optimization problem looks like. So optimization problem looks like, so first part is whether you are going to minimize or maximizing objective function, and that objective function value depends upon the two variables that is called as the decision variables, and we are trying to minimize the objective function subjected to some constraint. These are called as the constraints. Again, the constraints are two type of constraints. One is called as the equality constraint. So this is called as the equality constraint. 2x plus 3y equal to 10. This is called as the equality constraint. Whereas x plus y less than or equal to 1, that is called as the inequality constraint. So we have the equality constraints and inequality constraints. So equality constraint means that the equality sign will be exist, and inequality constraint means it contains some inequality sign, the less than or equal to or greater than or equal to sign. And coming to the different classes of the optimization problem, the classification of the optimization problem. So optimization problems can be classified into different categories. So optimization problem can be classified into two categories. One is called as linear optimization, and another is called as non-linear optimization. So linear optimization and non-linear optimization. How we decide whether it is a linear optimization or non-linear optimization? In the linear optimization problem, your objective function and your constraints all are in the linear function of your decision variable. Linear function of your decision variable. Your linear function of your decision variable. That means if trying to minimize some 3x plus 2y, then we can call it as a linear optimization problem. Because your objective function is linear function of x and y. There is no square terms, there is no cube terms, there is no trigonometric terms. So these are simply a linear relation. Your objective function is a linear function of your decision variables x and y. Then it is called as the linear optimization problem. And coming to the non-linear optimization problem means your objective function either minimizing or maximizing, your objective function will be a non-linear function of your decision variables. So if your object function is a nonlinear function of your decision variables, then we can call it as a nonlinear optimization problem. Okay, hope you understand what mean by the linear optimization problem and what mean by the nonlinear optimization problem. So linear optimization problem, your object function is linear function of your decision variables, and whereas your nonlinear optimization problem, your nonlinear optimization objective function is nonlinear function of your decision variables x and y. That is called linear and nonlinear. So in the linear optimization problem, your object function maybe looks like 3x plus 2y, linear function of your decision variables x and y, where in case of nonlinear optimization problem, your object function is x square plus y square. That is the nonlinear function of your decision variables x and y. And again further, this linear and nonlinear optimization problems are further classified into two categories again. So one is called as the unconstrained optimization problem and constrained optimization problem. Again, nonlinear also can be classified as constrained optimization problem and unconstrained optimization problem. So what mean by the constrained or unconstrained optimization problem? So unconstrained optimization problem means your optimization problem will contain only objective function, there is no constraints. So here there is no constraints. So that means if your objective function is a your objective function is a linear function of your decision variables and that doesn't containing any constraints, then we can call it as a linear unconstrained optimization problem. So example is like this: minimize 3x plus 2y. That's it. No constraint. Then this type of optimization problem is called as the linear optimization problem. And what is that constraint optimization problem? So that means if your objective, if your optimization problem consists some constraints, then it is called as a linear constraint optimization problem. So that means, for example, you are trying to minimize 3x plus 2y. So 3x plus 2y means your objective function is a linear function of your decision variables x and y, subjected to some constraint like x plus y less than or equal to 1 and 2x plus 3y should be equal to 10, like that. Then we can call it as a constraint optimization problem. Why it is a constraint optimization problem? Your objective function is a linear function of your decision variables 3x plus 2y. So this is a linear optimization. At the same time, you have the two constraints. So that's why it's a constraint optimization. So we can call it as a linear constraint optimization, where in this case there is no constraint, so it is called as a linear unconstrained optimization problem. And coming to the nonlinear optimization again. So constraint and unconstrained. Unconstrained means your objective optimization problem don't have any constraints, either equality or inequality constraints. There is no constraints. So for example, like that, you are trying to minimize some function x square plus 2xy plus y square something. That's it. There is no constraint. Just you are trying to minimize the objective function x square plus 2xy plus y square. So this is called as a non-linear unconstrained optimization problem. Why it is an unconstrained optimization problem? Because in your optimization problem, you don't have any constraints. At the same time, your objective function is a non-linear function of your decision variables. That's why it's called as a non-linear unconstrained optimization problem. And second case is non-linear constrained optimization problem. That means your optimization problem will contain the objective function like x square plus y square. At the same time, you have some constraint like x plus y less than or equal to 10, 2x plus 3y equal to 10, like that, some value. So you have the constraints, at the same time you have the objective function, non-linear objective function, then it is called as a non-linear constraint optimization problem. Now we will first try to work with the how we solve the linear optimization problem in the Python and in the MATLAB. Later we will discuss on the nonlinear optimization problem and how we solve the nonlinear optimization problem in detail. We will discuss in today's session. Okay, so as of now, what I'm expecting is you are able to understand analogy between the human learning and machine learning, and you are able to understand what is the role of optimization in the machine learning, and hope you are able to understand what mean by the optimization, what are the different parts in the optimization, and what are the optimization techniques classification. So you are able to understand. So next we are going to move in the implementation part. First we will try to implement the linear optimization. I will not going in depth about the linear optimization, because in machine learning, whether it may be a ANN, CNN or simple machine learning models, we require the nonlinear optimization only. But when we are trying to understand the what means the nonlinear optimization, all those things, it's better to understand both. That is the reason why I am explaining the optimization from the basics, but not in depth in all the cases. So first I am trying to explain how we use the linear optimization, how we use the linear optimization problem to solve using the Python, and also we will discuss using the MATLAB, and later we will move to the nonlinear optimization. So coming to the actually I shared some notebooks with you, I think so. Yeah, so actually I shared the one my GitHub link. So the GitHub link, from now onwards, what are the codes which we are demonstrating as part of the FDP, we will share the complete information through this GitHub. You can download at any time. Okay, so now here first I am trying to work with optimization Python. So just click on optimization by Jupyter notebook file. So not now, you can just what I am doing, just follow it, and after session was completed, you can try at home. So once you are open that optimization.ipynb file, Jupyter file, you are able to see the screen, and here you can see the open in Colab. So here you no need to install anything on your computer. So all the exercises, all the codes we are going to implement in the Google Colab. So Google Colab is a open source platform offered by the Google to run the Python code. So you no need to install anything on your computer. If you have, you can proceed, no issue. But as part of this workshop, you no need of any standalone Python IDs on your computer. Just we are working on the Google Colab only. So Google Colab is one of the cloud platform, open source platform to run the Python files. Okay, so if you have a Gmail account, that is sufficient. That's it. Nothing is required. So once you coming to this page, so there is a called Open in Colab. Just click on Open in Colab. This will be opened like this. Okay, maybe it will ask for you login, like you have to log in with your user ID and password of your Gmail, because it's already signed in my computer, so directly connected. Now I'm trying to take one small case study to explain the linear optimization problem, how to solve the linear optimization problem. So I will explain one case study, and I will give the another case study as assignment. So no need to submit tomorrow only. So I will share one canvas link. Just write the code and just take the screenshot or whatever it may be. Just post it in the canvas. Post it in the canvas. I will share the canvas link by tomorrow. Fine. So coming to this optimization problem, see, so your problem will not look like a mathematics what I demonstrated earlier. In the earlier, I said that minimize 3x plus 3y. So like that, it will not be available. That will be available in the form of the text format. Some instructions given by the client, those instructions will be shown to you like this. So let us assume I am working for a company, and the company is a chocolate manufacturing company. I am working for a chocolate manufacturing company, and my manager gives the instructions like this. The instructions are, so consider a chocolate manufacturing company that produces two types of chocolates, A and B. That produces two types of chocolates, A and B. Both chocolates require, so if you want to manufacture the chocolate A, chocolate B, the plant requires milk and choco. So they require the milk and they require the choco as well. Both are required. To manufacture each unit of A and B, the following quantities are required. That means if the manufacturer want to manufacture one unit of A or one unit of B, what are the requirements? That is, each unit of A, if you want to manufacture one unit of A, requires 1 unit of milk and 3 units of choco. So if one A chocolate if you want to manufacture, then the plant will require 1 milk unit and also 3 chocos. 3 choco units are required. Similarly, if the plant want to manufacture 1 unit of choco B, then it requires 1 unit of milk and 2 units of choco, right? And the company kitchen has only 5 units of milk and 12 units of choco. The company has only 5 units of milk and 12 units of choco. On each sale, the company makes profit of 6 rupees for chocolate A and 5 rupees for chocolate B. That means if the company sell 1 unit of chocolate A, they will get the 6 rupees profit. If the company sell 1 unit of B, they got the 5 rupees profit. Now the question is, the company wishes to maximize the profit, how many units of A and how many units of B should be produced? Hope you understand. So now the requirement is how many units of A and how many units of B the company need to produce so that the company will get the maximum profit. Right? So it is the example for the optimization. Why is the example for the optimization? Because we are trying to maximize the profit of the company. We are trying to maximize the profit of the company. Right? So that's fine. Now everything will be in the text format. So we have to build in the mathematical modeling. How we build the mathematical modeling? Just see what I am doing now. So I want to develop the mathematical modeling. So based on this requirement, right? So see here, what is our objective? Our objective is we are trying to maximize the profit, right? So the objective is we are trying to maximize profit. But what is the profit? How we mathematically model the profit? How we mathematically model the profit? You can see here. Sorry. How we can mathematically model the profit? So see, a company wishes to maximize the profit. How much profit they will get? If they sell 1 unit of A, they will get the 6 rupees profit. If they sell 1 unit of B, they will get the 5 rupees profit. So I want to know how many units of A, how many units of B the company need to produce, manufacture, so that they will get the maximum profit. So let's assume I suggest that X units of A and Y units of B. X units of A chocolate, Y units of B chocolate. If the company is able to manufacture, then they are able to get the maximum profit. Now our goal is we need to find out what is the value of X and what is the value of Y. X means number of units of A type chocolate that company need to manufacture. Y means number of units of B chocolate need to manufacture to get the maximum profit. That is X and Y. Now how we can mathematically model the profit, maximize profit, that profit mathematically modeled as, how we can mathematically model that one? See, for 1 unit of A, they get the 6 rupees profit. For a unit of B, they get the 5 rupees profit. If it is X unit of A, how much profit it is? 6x. If Y units of B, then how much profit they will get? How much profit? 5 rupees per 1 unit of B. So 1 unit, 5 rupees. For Y units, so 5y. So this is your objective function. We are trying to maximize 6x plus 5y. So we are trying to maximize this one. Now this is an example for the linear optimization problem, 6x plus 5y. Linear optimization problem. Why? Because your object function is a linear function of your decision variable. Decision variables are nothing but the X and Y. So X is nothing but the number of units of A and Y is nothing but the number of units of B. Need to company manufacture to get the maximum profit. So now we have the basic requirement of the optimization problem. We have the objective function, we have the decision variables. Decision variables are X and Y and object function is 6x plus 5y. Now still you can go with the problem statement, not completed. Your mathematical modeling is not completed. What else? See, each unit of A requires 1 unit of milk and 3 units of choco, and each unit of B requires 1 unit of milk and 2 units of choco. So based on this, and how many number of units of milk is available here? We have the how many number of available? So that is the 5 units of milk is available, 12 units of choco is available. Right? So how we incorporate these two statements in the mathematical modeling? So how we incorporate these two in the mathematical modeling? Okay. Now see. So see, coming to the milk unit, for 1 unit of A required 1 milk unit, 1 unit of B required 1 milk unit. So here you can see how many units of A, X, how many units of B, Y. Then how many units of milk is required? 1 unit of A, 1 milk. 1 unit of B, 1 milk. So X units of A, X milk, and Y units of B, Y milk units are required. And this should be less than or equal to, how much? You can go with this one. So once each year the kitchen has only 5 units of milk only. So for X units of A, see, for each unit of A requires 1 unit of milk. Each unit of B requires 1 unit of milk. So if X units of A require X units of milk, Y units of B requires Y units of milk, and total units of milk available are 5 only. Then what we can write here? X plus 5 less than or equal to 5. And what else? Anyone can tell how we incorporate the Charco related constraint in the mathematical modeling? Anyone can please respond. So how we include the constraint related to the Charco?
3x plus 2y.
Yes. So 3x plus 2y, that should be less than or equal to x. So we can write here it is a 3x plus 2y less than or equal to 12. Less than or equal to 12. I hope you understand. So because there are 3 x units are x number of A units, that is 3x. Y number of B units, there is the 2y. Chocos required. So 3x plus 2y, total number of chocos available 12. So less than or equal to 12. So that is also one constraint is included. And what we are going to identify? We are trying to identify number of units of A and number of units of B so that the company will reach the maximum profit. So we are trying to identify the X and Y. So definitely number of units of A chocolates, number of units of B chocolate never be negative. We say that 1 unit, 2 units, 3 units, 5 units, 100, 200, whatever it may be. We don't tell minus 1 chocolate, minus 2 chocolate, no. So your decision variables in this problem, your decision variables are only real positive numbers, positive integer numbers. So you can keep the another constraint x and y should be greater than or equal to 0. You may give solution that don't manufacture B type of units, don't manufacture A type of units. You can give solution like that, but don't give the solution that you can manufacture A type units minus 10. What is minus 10? Okay, so number of units may be a 0 or maybe a positive. Hope you understand. Now the mathematical modeling is for the optimization problem is completed. Mathematical modeling for the optimization problem is completed. Now we are trying to implement this in Python first. So we have some libraries in the Python. So you can use that one here. See, so this is a mathematical modeling already shared with you. So 6x maximize 6x plus 5y, x plus 5 less than or equal to 5, 3x plus 2y less than or equal to 12, and x and y greater than or equal to 0. So this is the mathematical modeling of the given optimization problem. And only one correction here is either in the MATLAB or in the Python, when you want to use any methods related to the linear optimization, so that will be valid for the minimization problem only, not maximization. Hope you understand. So you have to convert this one into the maximization problem to minimization problem. How? If you try to maximize 6x plus 5y, that means you are trying to minimize minus 6x minus 5y. Only that change you have to incorporate. So because we have in both Python and in the MATLAB, we will try to solve the linear optimization problem in the form of the minimization. So if you have the maximization problem, you have to convert into the minimization objective function just by keeping the negative sign. If you have the minimization problem, no need to do anything. You can use as it is. But if you are trying to attempt the maximization, problem, then first to try to convert into minimization problem, then you have to use it. Okay, hope you understand. So now our problem is converted as minimize minus 6x plus minus 5y and x plus y less than or equal to 5 and 3x plus 2y less than or equal to 12 and x and y should be greater than or equal to 0. Okay, now I want to solve this problem. So how we solve this problem using the Python, just see here. So already the codes are available here. So we have a method called linprog in Python. So similarly, we have the MATLAB also, we have the linprog. So same function in the MATLAB also, the name is a linprog. In the Python also, we have the linprog. So from scipy.optimize is the optimization problem. So scipy.optimize, import this method, this function. So import linprog function. The linprog function is used to solve, a linprog method is used to solve the linear optimization problem. Linear optimization problem. Fine. So once you are imported this linprog method, then you have to build some matrices. First, you have to build the matrices related to the optimization problem, sorry, objective function, matrix related to the equality constraints, and matrix related to the inequality constraints. So what is the matrix? So I want to redraw here. What is the matrix? These two are the inequality constraints, right? So how we convert it to the matrix format? So we can represent one as a, here x coefficient is 1, y coefficient is 1. In the second one, x coefficient is 3. Here y coefficient is 2. That is the coefficient matrix multiplied by your decision variables x and y. So that's equal to what are the constant values? That is the 5 and 12. So this is called as the left hand side of the equality sign. This is the right hand side of the equality sign. This is called the coefficient matrix, and this is called the constant matrix for your inequality constraint. Sorry, less than or equal to. So inequality constraint. So you have to prepare these matrices and you have to feed it to the Python. And also you have to prepare this objective function also. How we prepare this objective function in the matrix form, you have to prepare. So minus 6x minus 5y can be written as minus 6 minus 5, one matrix. And you have decision variables x and y. So minus 6x minus 5y, this is 1. So this is the object function matrix, and this is the inequality coefficient matrix, and this is the inequality constraint matrix, sorry, constant matrix. So you have to feed all this information into the Python. So first object function matrix obj is equal to minus 6 comma minus 5. Why minus 6 comma minus 5? Because we are converting maximization problem to minimization problem by keeping the minus sign, minus 6x minus 5y, and converting to the matrix format minus 6 and minus 5. So this minus 6 and minus 5 I am feeding here. Minus 6 comma minus 5. And coming to the inequality sign left hand side, LHS inequality and RHS inequality. So in the inequality side here, left hand side of the inequality side, we have the 1, 1, 3, 2. That's what represented here. So 1, 1. This is called within the bracket. I am keeping like this. So this is the one row, 1, 1. And this is the another row, 3, 2. So 1, 1 and 3, 2. So it's the 1, 1 and it's the 3, 2. And close the matrix bracket. So you have to call the matrix like this. Okay, hope you understand. See, left hand is the inequality constraint. Left hand side of the inequality constraint 1, 1, 3, 2, and right hand side of the equality sign 5 and 12. So 1, 1, 3, 2, and right hand side of the inequality sign we have the 5 and 12. Simply keep 5 and 12. That's it. So we feed the objective function matrix. We feed the left hand side of the inequality constraint. We feed the right hand side of the inequality constraint. Now you have to feed the boundaries also. Boundaries of your decision variables. So what are the boundaries of the decision variables? Your boundaries may be x comma y greater than or equal to 0. That may be 0 or positive. Positive means any value from the infinity up to infinity, any value. That's what I am representing here. Boundaries equal to. So this is corresponding to the, because we have the two variables, right? So this is corresponding to the variable 1 and this is corresponding to the variable 2. So for the variable 1 x, the lower boundary is 0 and upper boundary is infinity. And here lower boundary is 0 and upper boundary is infinity. We have to represent like this. So we have that means your x and y values, any value from the 0 to infinity. So after calling all these values, now you have to call the linprog method. You have to call the linprog method. So OPT, some variable, you can give any variable here. You can give x, y, whatever it may be. I am giving the OPT, some variable OPT equal to linprog. So linprog. So,
mechanical right the differential equation and right the term equation. Next, take a Laplace transform. Giving expression
So OPT, that is the variable which catches the output of your Lindbergh method, equal to, so C means your cost function or the objective function, that is nothing but your objective function OBJ matrix. OBJ matrix minus 6 minus 5, that is the objective matrix, objective function matrix, that called as a cost, C equal to OBJ. And this is another variable AUB, that nothing but that holds the left hand side of the inequality constraint matrix, that is called 1132. And BUB, that is the constant value, that is the right hand side of the inequality constraint. So that is generally why I am telling all the things means, see, your optimization problem in the Python, you are working like this. So minimize your objective matrix multiplied by your decision variable matrix, and subject to constraint A underscore inequality into X equal to B underscore inequality. So left hand side of the inequality sign is A underscore inequality, right hand side of the inequality sign called as the B underscore inequality. Okay, so that's what I am calling here. Sorry, A underscore, you can give any variable here. So A underscore UB, that means this is what? UB, and B underscore UB. So that is means you have to feed the left hand side of your inequality constraint matrix, right hand side of your inequality constraint matrix, and you have to feed the boundaries of the X and Y. Here already we are assigned the boundaries, so the same thing we are going to assign. And method, so actually to solve the linear optimization problem, we are going to use different types of optimization procedures. Methods are available, like simplex method, dual simplex method, interior points method. So different methods are available. So here you have to give the which method you want to use. So I am using the simplex method. That's it. So this single statement is required to solve the linear optimization problem. But of course, if you want to run this single piece of line, you require all this information. What the left hand side of the inequality sign, what the right hand side of the inequality sign, what are the boundary values, what are the object function matrix, all the information you have to feed it. So once you feed all those things, you can type OPT, that is a variable, dot X. That means X means the decision variables, X and Y, that will give. So dot X means that the decision variables, that value will be given. So now simply in the Python, this is called as the code cell. In the code cell, you can see an arrow button. So if you click on this arrow button, that will be executed. So it will be running means it is executing the cell code. So this tick mark means the cell code is successfully executed. You can see a green color tick mark. That means the cell code is successfully executed. Okay. So then you can the solution is you are getting this one. Output is a 2 and a 3. That means what I am suggesting now to my manager, to my company, manufacturing company, that is, if we are able to manufacture 2 units of A type chocolate and 3 units of B type chocolate, then we are able to get the maximum profit based on our constraint, based on our requirements. So the company is able to get the maximum profit if we are able to manufacture 2 units of the A type chocolate and 3 units of the B type chocolate. So hope you understand how we can use the, just go through this piece of code. I hope understand every useful of the each line. So go through it, and this code can be useful to solve the first assignment in Python related to the linear optimization problem. Now, so this is the assignment 1. So you have to solve this assignment 1 using the Python. So complete problem case study is given in this assignment. You are trying to convert it to the mathematical modeling. Later you are trying to apply this piece of code and try to give the solution, and you have to upload that one to the canvas. So this is about the solving the linear optimization problem in the Python. Now we will try to work with solve in the MATLAB also. Now we will try to, because we have the different type of peoples. So some peoples maybe work with Python only, whereas some peoples, especially from the electrical background and the mechanical, civil and the electronic background, these peoples are generally using the MATLAB. So I'm trying to explain this problem in the MATLAB as well. So, but as a participant of this course, we are going to solve this assignment 1 in both Python and as well as in the MATLAB. So you have to submit the mathematical modeling of the problem assignment 1, and also you have to upload the Python code, and also you have to upload the MATLAB code. So here also same in the MATLAB also we are using the same process as we use in the Python. So for example, here what is the problem statement? Minimize minus 6x minus 5y subjected to x plus y less than or equal to, I think 5, and 3x plus 2y less than or equal to 12. That's it, I think so. We will see. Yeah, 3x plus 2y less than or equal to 12. X plus 12 less than or equal to 5. This one. Fine. So now actually in MATLAB also we have a linprog method. So that also we can use like you can use OPT or X, whatever the variable you want to use. You can call linprog method. You can call your cost function or objective function, and you have to use A underscore IEQ, that means inequality constant, B underscore IEQ, that is the equality constant constant value, and similarly A underscore EQ, that is the equality constant A value, B underscore EQ, that is the constant value of the equality constraint, and also you have to pass lower boundaries, and you have to pass upper boundary, you have to pass the method which you want to use. So whether you want options, it's called as options. By default, it is uses the simplex method. So bar you can feed what method you want to use, you can feed that one also as well. So what the AEQ means, so you can write minimize, but only one thing is here in case of MATLAB, we can treat this one as a F transpose of X. We can represent your object function as F transpose of X. So how it will happen? If I want F transpose of X equal to minus 6x minus 5y, your F should be minus 6 minus 5 transpose and X. So X means X and Y. Then only you will get this one. So minus 6 minus 5 transpose means minus 6 minus 5 and X and Y. So that means this is called as your F. So F should be a column matrix. F should be a column matrix. And coming to the here, you have the A underscore IEQ, that is the coefficients of the inequality matrix, inequality constraint into variables X less than or equal to B underscore IEQ. This is a variable representation. Don't think much. This is a representation of the variable matrix. A underscore IEQ means coefficients of all the definite variables and the inequality constraint. B underscore IEQ means constants of all the inequality constraints. Similarly, if you have the equality constant, A underscore EQ into X would be equal to B underscore EQ. So A underscore EQ nothing but the matrix of coefficients of all the definite variables in the equality constraint. So B underscore EQ means the constant values of all the equality constraints, BEQ that contains. Okay, and LB means lower boundaries of your variable X and Y, and UB means upper boundary of your variables X and Y. You can give as a infinity or you can give as a blank also, no issue. So how we use this one now? Tell me. So A underscore IEQ is nothing but the 1132. B underscore IEQ nothing but the 512. Whereas the A underscore EQ, B underscore EQ, there is no equality constraint in our problem. In our problem, we don't have any equality constraint. So you can feed A underscore EQ equal to a blank one, B underscore EQ equal to a blank one. That's it, like that you can feed in the MATLAB. So, I think already shared the MATLAB code also in the GitHub. Yeah, we have MATLAB code for the linear optimization. Here you have the linear optimization. So click on that one. So this is the MATLAB code. So just you can copy this complete code. I will explain. So what the importance of each one. This is the MATLAB window, command window. I think someone have a basic knowledge. So this is the command window where we are able to see the output. Now I want to write the code. To write the code, just click on this new script. Just click on this new script. Just click on the new script and simply paste it. Okay, now save this code. Just I want to save this code somewhere in the D drive, some CMPS lab. So I want to keep it as a linear optimization. I want to give the title of my MATLAB file, linear optimization. Now see, CLC, nothing but the clear the command window. This is a command window, right? So I want to clear this command window. No data is available. If something available earlier, if the CLC command was executed, everything will be erased from the command window. Actually, it is a clear all, ALL. Clear all. So clear all means actually in the workspace no variables are there. If any variables are there, that workspace also cleared by using this clear all command. Now coming to F matrix. What is the F matrix? See. So here I am explaining. What is the F matrix? F transpose. This transpose F equal to -6 -5. It is a column matrix, not a row matrix. Right? F is a column matrix, -6 -5. So F equal to, open the bracket, close the bracket, inside -6, you have to keep semicolon. I will write here. If I write A equal to -6 space -5, suppose if I write like this, then it will be like a row matrix, -6 -5. But actually I want a column matrix, so A equal to, open the bracket, -6, you have to keep semicolon to move to the next row, and -5, close the bracket into. So now it is a column matrix. So that's why I kept the F equal to -6 -5 and separated by a semicolon, because it is a column matrix. -6 and next row is a -5, like that I have to. And there is the A matrix, that means what's called A matrix means inequality. The inequality constraint, what are the coefficient of your decision variables x and y? That is called as the A matrix. Okay, so A equal to, so matrix already we build. So A equal to 1, x coefficient is 1, y coefficient is 1. Here f coefficient is 3, here y coefficient is 2. So 1, 1, 3, 2. And what about the constant matrix? Constant value 5, 12. 5, 12, but it must be a column matrix. So this is the for the equation 1, this is for the equation 2. So your 5, 12 should be a column matrix, right? You can see here how we represent this one in the matrix form. So it is a 1, 1, 3, 2. That's into x and y. That's equal to 5 and 12. So these are the column matrix. 5, 12 is a column matrix. So that's what we are using here. So 1, 1, first row completed. Semicolon is that move to the second row. Now it is 3, 2. So that also included. So close the matrix. And coming to the B matrix, it is the column matrix. With the column matrix, first element is the 5, second element is the 12. So 5 and 12 separated by a semicolon. It is a column matrix. And what about the coefficients of x and y in the equality constraint? No, because in our problem there is no equality constraint. So that's why I keep the blank matrix. And B equivalent to, that's equal to, again it is a blank, because nothing is available, the empty array. And the lower boundary is, what is the lower boundary? So lower boundary equal to 0 and 0. For x it is the 0 and y it is the 0. And for upper boundary, for x it is the infinity and y also infinity. So you have to feed the upper boundary and lower boundary also. That means 0 to infinity, 0 to infinity. So your x value is varying from the 0 to infinity and y value is varying from the 0 to infinity. Okay. And now after that, up to here it's fine. After that, what you have to do is you have to use optim options. Optim options. What optim option function? It will give the information about which type of algorithm you want to use. So whether you want to use the dual simplex method, if you want to use the interior point legacy method, or you want to use the interior point method. So options equal to optim options. So for a linprog method, the algorithm is interior point method. Interior point strategy I want to apply to solve this linear optimization problem. Now you can use the linprog method. Similarly, what we did for the Python. X equal to linprog, pass the your cost function or objective function matrix, pass the your inequality constraint coefficient matrix, pass the your equality constraint inequality constraint constant matrix, and pass the coefficients of your equality constraint, nothing is there. and pass the constants of your equality constraint, nothing is there, and you have to pass the lower boundaries of the x, you have to pass the upper boundaries of the x. Here we are using the blank value. Blank means sometimes we need to give the initial values of x and y also. Sometimes we have to give the initial values of the x and y also. But in our problem statement, there is no initial values, so that just I kept the blanks like this. No initial value, so just I kept a blank. And later you have to call the options. Options will tell which type of algorithm, which type of methods want to use. So this is what. Okay. So now I am using the linprog method. How? X equal to linprog of F object function matrix, A inequality constraints coefficient matrix, B inequality constraint constant matrix, A equivalent coefficient matrix in the equality constraint, constant matrix in the equality constraint, lower boundary, upper boundary, initial values of x and y, and options. That's it. So simply you can run this code. Click the change in folder. So maybe actually in the morning I executed the code in the MATLAB 2021. So looks there is an issue in the version optimization completed because the objective function is non-decreasing. Wait. Yeah. So sorry, just see in the MATLAB, if you terminate any one line with the semicolon, the output will not be printed. So what I'm doing is just I press enter and type the variable name. X is nothing but a variable which holds the values of the decision variables. Okay, otherwise you can use some other variable also. You can use a variable called OPT opt. And that way you can here also you have to use OPT opt. So OPT is a variable which holds the optimal decision variables, the optimal values of the decision variables at which your company will get the maximum profit. So now execute this one. There it is. Oh sorry, by mistake. That's it. See, so that means it is also going the solution. So there is a 2 units of A and 3 units of B should be manufactured by the company to get the maximum profit. Hope you understand how we use the MATLAB to solve the linear optimization problem. So simple, it's almost similar to your Python also, but a slight variation because in the Python you can directly call the method just by using the double quotes, but whereas in the MATLAB you have to pass through the options. That's it. So this is the piece of code that will be useful to solve any linear optimization problem using the MATLAB. And previous one I shared the Python implementation of the implementation to solve the linear optimization problem using the Python, right? So now it is the 3:20. So we will take a break around 10 minutes, and we will join by 3:30. So from 3:30 to 4:30, we will try to discuss on non-linear optimization problem. So non-linear optimization problem is very interesting and very important those who want to work in the machine learning, because in machine learning we face the non-linear optimization issues. So how we tackle those non-linear optimization issues, that we are using the gradient descent optimization method, that we are going to discuss in the next 1 hour. So we will discuss about the implementation, and we discuss about some small calculation with some basics we are going to discuss. So now I want to stop. The session will be open, but we will take a break for the 10 minutes, and we will join back by after within 10 minutes by 3:30. I request all please join by 3:30 without any delay. Don't leave the session. I request don't leave the session, because if you leave the session and if you rejoin, if I am in a class, I can't admit you again. So please be in the session only, and you could go to some choice like that, and please come back, and we will start the session by 3:30.